Welcome to episode 2 of The Lone Teacher. You're sure ready for another day of e-learning. I'm excited, and I even have a new hat, and a student was kind enough to loan me a horse. This horse's name is Curly. Curly, are you ready for another day of e-learning? It's exciting. So make sure you have everything you need, and I hope you can come along for the ride. Curly, Mingo, are you guys ready? Yes. Hi-yo, Curly, away! Hello, Curly and I here for another day of geometry notes on e-learning, and we're excited to start in. And so, Curly, are you excited? Yes. And so, Curly, what's that? Curly says that Mr. Nice and the mask over your eyes isn't going to keep you well. You need to put it over your mouth. Well, Curly, if I put it over my mouth, I'm not going to be able to talk very good and teach very good. So we'll just, oh, Curly, whoa, Curly's falling and he can't giddy up. And so we'll just let him down there and we'll take the mask off and the hat off and we'll get started here. Make sure you print it off your notes. We're going to be talking about reflections. We're going to each of these lessons now. We overall talked about transformations last time, and this time we're going to talk about reflections, and then we're going to do some mini golfing from our own pencil and paper on Wednesday. But today we're going to get our red mirrors out. And so if you have the red mirror right here, and so Curly, he likes to just look in the red mirror and go, whoa. And so, but you need these. If we had these in school, everybody'd be going like, oh, look, everything's red. But you're here by yourself. And you need to stop bugging me about making a new seating chart. I'm not making a new seating chart. You're just going to have to put up with the seats you have right now, and they're going to have to be good enough, okay? But we got all you guys here, and so we're glad that you're here, and we're going to start in. And so we're going to use the red mirrors, and I will kind of show what we're going to do by using a red line and how we're going to place it on the paper. And so take your notes out, and the first thing it is we're going to try to use the mirror on the notes to match up as many points as possible. There are images and there are pre-images. And so where do you want to put the red line so that we could match up as many points as possible? If we put the line here and you put the mirror on the paper, where that red line is, put your face on one side of the mirror, look in the mirror and try to put points on top of other points. And if you put the mirror right there, you might only be able to get, like this dot on top of that dot. You're not getting very many, okay? So let's try the mirror again, and maybe we'll move it this way. And will that get any points on top of another point? Well, maybe you'd get this one on top of that one. And that might be about it. And so where else could we put the mirror? We'll give you a little bit. You can pause the video and figure out where can I match up a point and its pre-image and how many can I get. You should be able to get 8 pairs of pairing up. And so If you don't want to see the answer, you better pause it, because here comes the answer. And so if you put the point, we better zoom this out a little bit. If you put the mirror right here, kind of like that, we should be able to match up 8 pairs of points in their preimages. And so kind of place the mirror right there and then see which points will pair up. And so the points that will pair up should be this one with this one, 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 this one with this one. My line might be off a little bit, but we'll fix that. This one with this one, this one with this one, and this one with this one. And what we're going to do is you can take that straight edge of the mirror and we can draw in lines. And I'm going to try to just off-center them, and then magically they're all going to get perfectly centered back, I hope. And so let's see what happens here. And so there's several things I want you to notice when we connect these preimages to their images. Yep, it all worked perfect. And so first thing you're going to notice is that when you have a point and its reflection, this point and its reflection, the first thing you're going to notice is that they are the same distance from the mirror. And so we can mark this. This point is the same distance from the mirror as this. This point right here is the same distance from the mirror as its preimage. And so since on this we can't tell which point came first, the image or the preimage, the chicken or the egg, the circle or the pie, we will just mark them both. And so this distance is the same as this one. And this distance is the same as this one. I should do 4 marks, but we'll just go back. I'll just treat all these as separate problems. We'll just make a mark. This is equal to this, 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 and this is equal to that. And so make sure you have all that. So the first thing you notice is that when you're standing in a mirror, you are the same distance from the mirror as the image. So you got this same distance from the mirror as the image. And so I said before, sometimes when I'm getting ready in the morning and I'm brushing my teeth, one of my favorite things is to talk to the right-handed Mr. Nyson, because the left-handed Mr. Nyson gets to talk to the right-handed Mr. Nyson, and many times we'll race on who can touch the mirror first. And I will try to touch the mirror and the reflection, and you know what? It's always a tie. And so I'm always trying to break the tie. I just say, one more race. Who can touch the mirror first? And then it's a tie again. Then we go, one more race. And then it's a tie again. And then we try one more race. And then it's a tie. And so it's still been a tie, and I just had to come make these videos and stop brushing my teeth because it always ends in a tie. And so, but the distance of the image and its preimage are always the same. And the other thing you should notice from the picture is that the line connecting a point with its reflection is always perpendicular to the mirror. And that's very important on some of the homework problems tonight, because we locate one of the slopes and then we take the opposite reflipical to get the other slope. And so the slopes will always be opposite reciprocals because these are perpendicular. So you can make a little box. That's perpendicular. That one's perpendicular. The lines connecting the images to where the mirror is located will always be perpendicular. And perpendicular slopes are opposite reflipicals on that. Okay? So you need to make sure you get all that down, because when we get back to school, I'm grading your notebooks, and they're worth 200 points. Well, 200 points. And so you need to make sure your notes are good, and that you're getting these printed off and they're filled in. Okay? So, a couple other things. Take your mirror, and we're going to draw in some lines of symmetry. Okay? So, scroll on down, and we'll give you a second. You can pause if you want to draw the lines of symmetry in first, but we have a few shapes. And symmetry means same on both sides. We're symmetrical. See? Same on both sides. And so this is a line of symmetry. This isn't. You know, I don't have a mouth up here. I don't got eyes down here. And so line of symmetry is right here. So on the picture, we want the line of symmetry. And so are we ready? One line of symmetry, you can put the mirror, would go right about like this. Mine aren't going to be perfect because I can't really place the mirror. Here, I'll place it on the computer screen. Can't really tell, can you? And then the other one will be here on this ellipse. There's like 2 lines of symmetry. On the rectangle here that's not a square, how many lines of symmetry would we have? Well, we have one right here. And there'd be another line of symmetry right there. For the square, do we just have 2 lines of symmetry? Tim, is there just 2? Oh, good, Tim. No, yeah, there's 4. Because we have the 2 since it's a square. There is a little theorem we could prove that if you have a regular n-gon, n sides, it has n lines of symmetry if it's a regular polygon. So a square has 4 sides the same, all 4 angles are the same, and it has 4 lines of symmetry. Well, there's our 2. Tim, where are the other 2? Oh, yeah, go corner to corner. Great job. And so we go right here to corner, and then there corner to corner. So a regular four-gon would have 4 lines of symmetry. A regular pentagon would have 5 lines of symmetry. A regular hexagon would have 6 lines of symmetry. Which brings us to Mr. Circle. How many lines of symmetry does the circle have? Well, it has 1. It has 2. It has 3. It has 4. It has 5. It has 6. It has 7. It has 8. It has 9. That wasn't a very good one. 9. We could be here all day. In fact, a circle has infinitely many sides. Therefore, if a regular n-gon has n lines of symmetry, does a circle have no sides? Or does it have infinitely many sides? And so you know what I think. It has infinitely many sides, and so it has infinitely many lines of symmetry. So you'll never finish that problem, so you can just work on it for the rest of your life. And when you're done, you still have infinitely many lines of symmetry still to draw, so you're not even close. But flip it to the back side, and we'll do some problems that you would be expected to do on your homework tonight or today that you can email me. Many of you are doing a great job at emailing me your assignments. You know, just try to, if you hold the camera vertically and the paper vertically and zoom in, and don't try to keep any border. If you have a lot of border around the edge, it just uses more toner on Mr. Nison's printer, which is okay. But, you know, you can just go right up to the edge, and I print it, and I write your name if I can't see it. So it's all good. So let's take a look. On your homework tonight, it'll say, copy each figure on graph paper, which I provided, and then draw its reflection across the line. So the first thing you want to do is probably draw the line. So on the graph paper, it's not like coordinate counting or anything, so you can just draw the line. You can put a couple of them on. We'll do this one here. And then you can draw the image if you want. And so this one would go count squares. What is that? Slope of 3/4. And then we have this. And then we have that. And then if you're going to draw the image, just remember the distance from, whoa, see, that's what I don't like. Then it jumps over. And so then I got to move it back. Okay, move it back. And then we're going to draw the image. Well, the distance from this to the mirror is 2. So the distance from its reflection to the mirror is going to be 2. The distance from this to the mirror is 2. Therefore, the distance from this to the reflection is... Every point in this picture is going to move except for the one that's on the mirror. That one doesn't move because it's its own reflection. If you're in the mirror, you don't go anywhere. And so it's just if you're on one side, you flip to the other. Okay? And so we're going to draw this. And so this point goes here. So then that segment's there. And that goes like that. And then there's your picture. And so you copy the figure, draw the mirror, and draw the image. Okay? So we're going to do the same thing here with this one. And we'll draw the line with the straight edge tool. Of course, everything shifts. And then we'll shift it back. And then we could try to trace the picture, which would look like this. And then we'll see how cool we are with the technology. And then you would take this and you just move it to wherever it looks like right there. Okay? And so then when we're ready for the flip, this is 2 away from the mirror. So it's going to flip 2 away from the mirror. And it's going to flip up here. This is 2 away from the mirror. So it's going to go 2 more to the mirror. But then if I'm on this side of the mirror already, I go to the other side. And so this one's going to go down here. And those are your 3 corners. And so then we connect it. And so the image of the reflection is the things on the left side of the mirror go to the right side, and the things on the right side of the mirror go to the left side. And if you're on the mirror, you stay on the mirror. You don't move. Okay? And so those are just the basic ones. And then now we're going to review some algebra. And so we're going to talk about flipping across certain slopes and y-intercepts and vertical lines and horizontal lines. And so you need to remember this, but the next ones are going to look like this. And so on these, we got a coordinate system. And so it says, draw this picture and flip it across the line, x equals 2. Well, we take this picture. Ooh, that was pretty bad. And I'll just draw it down here. And so you go 3, 2, just count your slopes so you can kind of know where it ends. And this has a slope of 1/2. And that has a slope of -1, and that's vertical. And then it says, flip it across the line, x equals 2. Well, x equals 2. Is that going to be a horizontal line or a vertical line? And so what do you think it is? Avery, is x equals 2 horizontal or vertical? Avery, yes, x equals 2 is vertical. And so we're going to draw in that line where the mirror would be. Whoa, not right there. And so the mirror would be right there at x equals 2. And so if we're going to flip that, the things on the left side are now on the right side. So that's going to look like that. The things on the right side are now on the left side. And so your picture across the line x equals 2 looks like that. Okay? And so you have that. Now we're going to take the picture and we are going to flip it across the line y equals the opposite of x minus 5. Well, y equals mx plus b. What's my m? What's my b? And what is the m and what's the b? Damien, what's the m? -1. That's good. And what's the b? 5. No, there's a negative sign, Damien. See the negative sign right there? And so it's -5. And so we're going to start at -5. And remember, negative slopes go downhill. And so, nice negative. Remember Slope Dude, all that stuff. You can watch him on YouTube. And so we got slope of -1. And so here's the new mirror. Now remember, we're going to flip the original image, not our new one. And I could draw a line, but my shaky hand will make it way too crazy. So there's our mirror. And so we're going to put the mirror on the angle, right? You know, put it right on that orange dotted line. And now we have to count our distances perpendicular to the mirror. So if this mirror has a slope of -1, you go out a slope of 1 and see you find this dot. Well, I'll keep it the same color. If this is 2 away on an angle, which is really 2 square root 2 away, then you go down here 2 square root 2 away, and that's the new dot. Well, this one is 3 on the angle away, so then that's 3 on the angle away, and it has to be perpendicular, and so that one's there. Well, some of you can see now that this side matches up with this side. So then this side is actually going to come straight down. And if you can't do that, then you could go perpendicular slope and figure out exactly where that is. But if you can see it, it goes like that. And so that's 5, and then this one comes up 3, and then this one goes over 2, and then this one has that slope. And so we have the two pictures. I'll shade them in for you. The original one was right here, and the flip across the line, y equals negative 1x minus 5, is right there. And that would be the reflection, okay? And so we're going to do, instead of flipping a shape now, we're going to flip a line. And so on this one, we're going to flip this line right here, y equals 1/2 x minus 4. So how would we graph that line? Charlie, how are we going to graph the line y equals 1/2 x minus 4? Remember, y equals mx plus b? Where are we going to begin? We're going to begin at 4. No, Charlie, negative 4. Yes, very good, Charlie. Negative 4. And so right there, negative 4. And then how are we going to move? Move. No, Curly, that was a cow, not a horse. Move, not. Okay. Now, and so we're going to rise 1, run 2. Rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2. And so, or drop 1, left 2. And so here is our line. And so it's not going to be that straight because it all shifts when I use the straight edge tool. But here's the graph of the original line. Now it says we are going to reflect this line across the x-axis. Well, if we reflect it across the x-axis, this is the x-axis. And that's our mirror. And so we put the mirror there, and then this part, the camera reflects my image, and I'm so reflected, I got to reflect on this a little. And so that's going to flip up, and so the bottom part will flip up, and the other part flips down, like that. And so let's graph the reflection. So if this one's up here, it's going to be down there. The point in the mirror doesn't move. This point now is up here. This point now is up here. This one is now here. This one is now here. Well, wait. There's some things we can notice. There's some things that change, and there's some things that don't change. When we look at this, a reflection in the x-axis, you have a point. I got to make the mouse a little smaller. You have a point xy. If you reflect it in the x-axis, all you're doing is taking the x and keeping it the same. But then the y becomes the opposite because it went above the line to below the line. It went above to below or below to above. We took the opposite of whatever the y coordinate was. And so there's our new line. Well, I can get this new line, y equals, what's my new m and what's my new b? Carson, what's the new m? Well, it's negative now, yeah, and it's just the opposite. It's negative 1/2. And then what's my new b? Oh, new b. Oh, the new b. What would that be? Kirsten. Oh, 4. Great job. And so negative 1/2 x plus 4 is the new line. But I could have gotten all of this without a picture. Because we're going to learn as we go through this unit that if we just substitute the opposite of y in for y, and we get the opposite of y equals 1/2 x minus 4. If we want to solve for y, we just got to get rid of this negative sign. So you multiply both sides by the negative sign, and you get y equals negative 1/2 x plus 4. That's quite amazing. And so the equation of our new line could be attained without. And so don't forget that. And that's why we got pictures and graphs for you tonight. And so on your homework tonight, you have the sheet. On the first ones, all you're doing is copying the image and reflect it and put those on the graph, make them pretty. It looks nice. And then when we get down to problems 7 through 14, I added a picture to my handout that you don't have just so I could help explain it. So on problems 7, 8, 9, 10, and 11, 12, there's actually 3 parts for each one. So if you just want to write right here, problem 7, part A, B, just go down your paper. And so you got 7 ABC. So 7 says we're going to take point A. Well, point A is the point, look at the graph, see over here, here's point A. It's the point 2, 4. Well, part A says reflect the point across the x-axis. Well, if you do, here's the x-axis, it's going to go down to here. And so that's the new point. Well, if you name it, that would be 2, negative 4. For part B, it says reflect the point across the y-axis. Well, here's the y-axis. This would be your mirror. And so it goes here, and then A would go over here. Well, that's the point, negative 2, positive 4. For part C, it says to reflect the point across the line y equals x. Well, across the line y equals x, that's right here. And so this point would go here. And then that becomes the point 4, 2. But math is all about noticing patterns and generalizing patterns. And I already can tell you how to do problem 7, 8, 9, 10, 11, and 12 right here. Because the first ones, what do you notice is the only difference between this and this. What do you notice? Grant. Oh, that you changed the sign on the y coordinate. I'll grant you that. And so that, in general, if they give you point xy, if you want to flip it across the x-axis, it becomes x opposite of y. This is like the secret codes. This tells you how to do every problem. Good guys wear white hats. Okay, part B, we're flipping across the y-axis. And so in general, what would that become? Jack. Yes, it becomes opposite of x, comma y, because you change the x value, but you keep the y value. Now, did Grace tell you that answer, or did you get that on your own? Good job, Jack Thomas. Good job. Now, the third one, when we flip across the line y equals x, notice, it means y is x. Well, if y is x, then y is x, or x is y. That just means the answer is y comma x. And a lot of these things become the way computers and things you can program to move shapes. You have coordinates, and you tell them to change it. And all of a sudden, it flips. Or it flips this way, or it flips this way, or it flips this way. And just by changing where a negative sign goes and changing a negative to a positive and a positive to a negative. And so the last couple for 30, 31, and then down to 32, 33, 34, and 35. Since most of you are not emailing me many questions, you're giving me your assignments. I ask you how things are going. Everything's going good. And so I'm going to set up the last ones also. And so, but before we do that, I wanted to let you know, I got this new book over the weekend. When I was little, waiting at the dentist's office or the doctor's office, one of my most favorite books to read was Where's Waldo? Now, don't tell Mrs. Smith that, because Where's Waldo's books don't have any words. And so if it's my favorite book to read, can you read a book without words? I don't know. Maybe we should ask Gaston. And so, but here is, one of my favorite books was Where's Waldo? But they came out with a new version. The coronavirus version of Where's Waldo. And it's just not the same. And so let me show you a couple pages of it. There's one page. Can you find Waldo? He's right here. Wasn't too tough. Then, here's another page. Waldo in the city. Can you find him? I'll give you a second. I remember when I was young, it took me a lot longer to find Where's Waldo. But now, since everybody's social distancing, Waldo, he's just right there. And then, we have another page of Where's Waldo. And here's Waldo on the beach. Can you find him? I'll give you a second. There he is. And so it's just not the same, but we thought you might enjoy the Where's Waldo coronavirus version. Now let's go to the last couple. The last ones on the homework say, now I just put my mouse over the picture, so now it shows this spacebar thing, which I don't like. But for the last couple, for 32, Well, let's move me over here so we can actually see this. Oh, then the sound bar went away. That was good. Okay, so problem 32 says, plot the point 5, 0 and plot the point 9, 0. And then it says, find the equation of the mirror. Well, where would you place the mirror if these were the two lines? Well, what you do is you connect the dots, and you want the mirror to be perpendicular and at the midpoint of that line. Well, if it's perpendicular and at the midpoint of that line, well, then what's the equation of that mirror? Well, that's a vertical line. So is that a y equals or is it an x equals? Megan, y equals or x equals for vertical lines? Now, the y-axis goes this way, but remember, every point on a vertical line has the same x value, same x coordinate. So this is an x equals. So this would be x equals 7, and that's the answer to number 32. Of course, you can put all this work on your homework. So I know you did it on your own. And then let's look at the next one. What's that? Taryn, you want to make sure we do an even one because you already got the odd ones in the back? Okay, we'll do an even one. Taryn, which one do you want to do? You want to do problem 36? Okay, we'll do 36. Problem 36 says plot the point 0, 2. Okay, that's right there on the y-axis. And plot the point 4, 6. Well, that's right there. Okay, so this is problem 36. Problem 36. You can make it all nice and neat over here. So what you do is you want the mirror to go through the middle and perpendicular to this line. Well, what is the slope of that line? Kaya, what's the slope of the line? It's 1. Of course it's 1. Great job, Kaya. Now, if the slope is 1, what is the slope of the perpendicular line? Vadim, what's the slope of the perpendicular line? You know, the opposite reciprocal. That's good. The perpendicular slope is going to be -1. And so we're going to cross the midpoint of this. Now you could find the point and then use point slope y minus y sub 1 equals m times x, quantity x minus x sub 1. But when in doubt, draw it out. And if you just draw this line, you will see that it crosses right there and has a b of 1, 2, 3, 4, 5, 6. A b of 6. So your answer for number 36, y equals mx plus b, is y equals -1x plus 6. And since it's your special day, we'll do problem 34 to get, well, 34 is horizontal and vertical. We'll do 37 because you'll look it up anyways. And so problem 37, last one on your homework. If we plot the point -1, 2, that goes right here. And then we plot the point 4, 5. We want the line through the middle and opposite reciprocal. Well, this one's a little trickier because where is this going to go? Well, the slope of this line is 3/5. So what is the slope of the opposite reciprocal? What is the slope? Beachy, what's the slope of the opposite reciprocal? Good job. -5/3. Yeah, don't forget the negative sign, Beachy. -5/3. But then where's the middle of this line? If I'm here at 4, 5, and then we're also at -1, 2, the midpoint of that line is what? What's the midpoint? Jacob. Yes, we would add these. That would give me 3, so it'd be 3 halves. So you add the x's and you average them. So that'd be 1.5. So it's going to be 1.5 or 1.5, comma. And then we add 5 and 2 together and average those. So that'd be 3. It's 3.5. And that's exactly where my red dot was. That is a 3.5. 1.5, comma 3.5. And so that's right there. And then we want to do the opposite reciprocal slope. So negative 5/3. Well, if you're a perfect plotter, you would see that if it's negative 5/3, here is another ratio. Give me a fraction that equals negative 5/3 that has a 1.5 on the bottom. If you went 5 to 3, it's what to 1.5? What would that be? Isaiah? What's half? Oh, we'll just take half of 5, so you get 2.5. And so a negative slope would be like negative 2.5, 1.5. Well, here, if you go over 1.5 and you go up 2.5, lo and behold, it perfectly crosses the y-axis at, whoa, that's pretty bad, 6. And notice how these slopes are perpendicular. And so that has a b of 6. And so the answer for problem 37 is y equals negative 5/3 x plus 6. And so we hope that you enjoyed today's videos, and I hope this explains it well. If not, just email me. We're at the computer. 9 to 3 are the school hours, and so we'll be getting some grades into Power School. And if you haven't sent me your assignment from last Wednesday, make sure I get that and work on these. You don't have to wait till Wednesday to send it to me. You can get it done and send it to me right away. And then we're going to use the concepts of reflection to do some mini golf, putt-putt, which I can't really show you in the air. So I hope you enjoyed, and until next time, na 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 na, hey, goodbye. Now, Curly, we got to figure out how to turn off the video. So where are we at? Right here.